So a scalar product is pretty much basically an operation that just takes two vectors and gives a real number. Okay, and I guess the scalar product is a means to an end in some respects. If I have two vectors, say A and B, and that's the angle in between, okay, well then the scalar product, well, let's take a back step, the scalar product, okay, which in reality is evaluated by multiplying the corresponding components. So the I components multiply together, the J components multiply together, the Z components the K components multiply together. We call that scalar product the dot product, so it's A dot B. Yeah, and I guess geometrically, another form of A dot B is magnitude of A, magnitude of B times cos of the angle in between. So the dot product itself relates to the size of the vectors that we're dealing with and also the angle between the two vectors. And there's some really interesting properties that we can extrapolate, I guess, from that little rule. So it's just some things to note. Any vector dotting itself, any unit vector dotting itself is one. And as it turns out, I.j, j.k, I.k, so those unit vectors that are dotting with the other unit vector is equal to 0. So let's just have a look at a bit of an example first, and we'll talk a bit more about its properties. So A dot B is simply equal to 8 times 1, which is the I components, 7 times negative 1, the J components, 3 times 3, which is the K components. What's that? 8 minus 7 plus 9, which is 10. A dot A, we're just dotting itself, so it's I components multiplied each other, J components multiplying each other, K components multiplying each other. So really it's just 64 plus 49 plus 9, which is 58, 62, 122. All right. So then, as I mentioned a little bit earlier, the description of the dot product is relating to the length of the vectors and the angle in between. So we can use this to rearrange our expression to get the angle of the vectors in between. Yeah, the angle of the vectors, or the angle between the vectors. All right. So we know that A dot B is given by multiplying the X component, Y component, Z component, or IJK. So cos theta is A dot B over mod A mod B. And that's a really useful little product or property that we make use of. So finally, A, B, C points are defined respectively. Find the magnitudes of the angle ABC. So let's have a think about that, angle ABC. So from A to B to C. So it's that angle there, okay? So the angle ABC is, and it's really important, it's the angle BA dot BC. So it's coming from a common point. So the angle between those two vectors, so they're the two vectors I'm interested in, BA dot BC. So the angle between cos theta is BA dot BC over magnitude of BA, magnitude of BC. All right, so we have to work out BA and BC first. BA is equal to BO plus OA, which is OA minus OB, A minus B, which is 1 minus 2, which is minus I, 3 minus 1, which is plus 2J. Same thing for BC, is going to be OC minus OB. So it's 1 minus 2, which is minus I, minus 2 minus 1, which is minus 3j. Magnitude of BC is equal to 1 squared plus 3 squared, which is 10. And maybe over here, the magnitude of BA is equal to 1 squared plus 2 squared, which is square root 5. So bring that together. Cos theta is equal to the dot product. So it's minus I plus 2j dot minus I minus 3j over magnitudes root 5 by root 10. So what's the top? Negative 1 times negative 1 is 1. 2 times negative 3 is minus 6 over root 50. So we can say cos theta is equal to negative 5 on root 50. So if we use our CAS for that, we don't even need a CAS in the end, do we? Negative 5 over 5 root 2, which is equal to negative 1 on root 2, which is equal to 3 pi on 4. So 135 degrees is the size of the angle in between. And if we do something similar for the angle CAB, so CAB is AB dot AC, is that vector there. Yeah, so it's really important to make sure you get the vectors the right way around. So we've got AB because it's the negative of BA. So AB is equal to I minus 2j. AC we can work out. AC is equal to OC minus OA, which is 1 minus 1, which is 0, and minus 2 minus 3 is just minus 5j. So the magnitude of AC is just 5. So cos theta is equal to A dot B. So we've got I minus 2j dot negative 5j over magnitude, so it's 5 times the magnitude of AB, which we said was root 5. So cos theta is equal to, well, 1 times 0 is 0, negative 2 times negative 5 is 10, over 5 root 5, which is equal to 2 over root 5, so we might need a CAS this time. Theta is equal to 26.56 degrees, 0.6 degrees to 1 decimal place. All right, so I guess some key things to talk about in terms of the properties of our scalar product, and it will come up a little bit more. Big one is here, A dot B. That's the one here I want actually. If two vectors are perpendicular, it means the dot product is 0. So if they're perpendicular, it means the angle between the vectors is 90 degrees, and cos of 90 degrees is equal to 0, isn't it? So that makes A dot B equal to 0, because the only way my dot product up here, if you like, the only way that can be 0 is if the dot product is 0. All right, constants can come out the front. Order is not relevant. A dot A is the magnitude of A squared. So that's a big one there. The A dot B equal to 0. The vectors are perpendicular. Okay.